Hello everybody and good morning. A warm welcome from Berlin. Today I'm with Alec, Field CTO of IBM Turbonomic, and we too like to show you a few topics around Turbonomic Application Resource Management and the integration into the Cloud Pak for Watson AIOps, most recent version 3.7. We're going to show you a few use cases, we're going to demo the whole thing, and we're going to talk about integration points. And let's switch over to the agenda. So firstly, we're going to show you what is application resource management, what kind of use cases there are usually. We're talking about sustainability, green IT, power savings, and so on and so on. So most of the buzzwords that we're using today. And we're going to integrate the ARM application into the Cloud Pak for Watson AIOps via tickets. So we're going to create tickets in Turbonomic, and we store them in a trouble ticket system, and that's the point where the Cloud Pak for Watson AIOps takes that kind of information and does modeling, learning, and all these kind of magic that the Cloud Pak can do. As soon as we see the Cloud Pak for Watson AIOps, we're going to demo what the Cloud Pak looks and feels like. We're doing a brief overview of what it is, and we're going to show you also a few use cases. So as we are using ticketing data, the obvious use case here that we're going to use is change risk management, and with that use case we're going to explain what is training, how to get data into the whole thing, what the modeling process is, and so on. I wish you a good time. Over to you, Alec.
Hi, my name is Alec Kemp. I'm the Field CTO here at IBM Turbonomic EMEA, and it's my pleasure to present into this and talk to you a little bit about the great things that Turbonomic can do, a few use cases, and we're going to deep dive into one particular one. So let's get straight into it. This is a chart that actually was put together by one of my very smart colleagues, Klein, and it kind of highlights some of the main talking points really down the right-hand side of this chart that you can see that customers will be interested in, kind of key topics that are present in the industry today. And there's a bit more detail on that use case in the kind of left-hand side column. We're really going to talk a lot about green IT, sustainable computing, power saving in this topic today, and I'm going to show you a brief demo, but there are other use cases, of course, that Turbonomic can handle. One of them that's very popular is around FinOps. You might have clients who've deployed FinOps reporting solutions that tell them how good or bad a job they're doing against their budgets and so on, but they won't have a set of tooling that's enabling them to manage that cost and take actions. You might have clients who are stuck on their cloud journey. Perhaps they've overspent, they've paused on that journey, they're kind of trying to figure it out. We've got great capabilities to help them with all of that. And finally, in this chart here, we've called out accelerating cloud native initiatives. So with our friends at Red Hat, clients are looking increasingly to move to more flexible Kubernetes types environments, possibly with OpenShift from Red Hat if they're doing it in a sustainable and clever way. However, it's still complex. Kubernetes is a complex environment. There's a lot of moving parts, a lot of dials and levers. It might be unfamiliar to those clients, and that can be a barrier to getting that cloud native journey off the ground. And Turbonomic really helps both in that familiar look and feel of the rest of the virtualization environment all in one place, but also in very specific actions that you can take at the Kubernetes layer that can be automated to help manage that very dynamic, rapidly changing environment. But as I mentioned, we're going to be talking today about green IT, sustainability, power saving. It can be expressed in different ways, but really we're talking about making the environment responsibly efficient. And by that, I mean making sure that the actions that we're able to take and recommend and come up with the decisions really that we're giving the clients automatable because they're safe. They're going to preserve performance first and foremost, and that's going to allow them to get the benefit of making the environment right-sized, fit for purpose, delivering the performance that they need always, but also in a very efficient way. And customers have got lots of different options and lots of different things they can do to help reduce their carbon footprint. IBM offer many different solutions in these areas, including much better hardware, different platforms, and so on. What I'm really talking about is operational efficiency, making what they have more effective, more efficient, using less compute power, less storage power, and therefore less power, therefore less carbon. And that's really important because electricity accounts for about 70% of a typical data center's operating costs. And within that data center, sadly, most of our clients that we come across are in the 20 to 40% utilization range, and that's been borne out across thousands of clients that we've worked with. When they move to public cloud, they actually externalize that problem, if you like. Now they're paying for it by the minute, which is very costly, but also they're kind of inducing their cloud providers, AWS, Amazon, and Google, to actually run hardware unnecessarily on their behalf. And so you can see how that plays directly into scope 1 and 2 in the on-premise world and scope 3 in the public cloud world, emissions being higher than they need to be. And so with Turbonomic, you can actually have an impact on all of those aspects. We've already talked about the ability in the data center to optimize by organizing the environment better, like a complex game of Tetris, I guess you could say, placing the workloads together in a more effective way to make better use of the existing hardware, scaling workloads up and down dynamically to only use what's needed to deliver the performance. In the public cloud, we're doing very much the same type of thing. Of course, in the public cloud, you want to select from a huge range of potential choices on an ongoing basis as the workload demand changes, as the offers from the public cloud provider change. And doing that can actually help you be more elastic. Having a decision engine that you have trust and confidence in can allow you to automate those actions and deliver on those benefits. And obviously in the middle there that I skipped over, the cloud migration planning, that's kind of middle step, right? It takes you from the data center into the public cloud. And we've got a what if analysis, a planning engine within Turbonomic that you can actually leverage to answer the questions like, what would happen if I pick this set of application workloads up from my on-premise data center and drop them into public cloud vendor X? What would that look like? How much would it cost? What type of application configurations would I need in terms of the images that I need to provision in the public cloud? And so that can really help accelerate part of the cloud migration planning. Not all of the answer, right? You still need to identify which applications you want to migrate, security. There's all kinds of things that we need to help clients with. But this particular part of the kind of the bill of materials, if you like, is really where Turbonomic can help. Without further ado, I'll jump quickly into the demo. I'll show you a few cool things, and we'll come back and talk about some customer examples in a second. So let me jump out of this and onto the demo instance here. So this is a Turbonomic user interface. Hopefully some of you have seen this before. We're kind of calling out here on an application basis where our kind of critical actions are that need to be taken. We can drill into all of the actions. Here is our supply chain that kind of illustrates from top to bottom the application demand at the top through all the infrastructure elements that are supplying that application. And at each layer, I can click through and see what type of actions are present. But let me kind of filter this down really and drill into a specific app just to give you an example. So this is an app coming from Instana called Quote of the Day. Probably not a super important app, but this is a demo lab. And we can see that this application's, not having a great day, right? It's an application running over 27 transactions with a bunch of application components running in 10 containers. And we've got a huge amount of actions here to help remediate these problems. Ideally, in a real world, you would actually automate these actions because you'd have built up confidence and you'd have policies in place to automate them. Obviously, it would be a very dull demo if I didn't have any actions. So we've kind of set them into a manual mode, which means I can click and apply them should I wish. So a bunch of these actions are performance reasons, but there are also actions to kind of move things around to prevent future issues and organize the environment in a better way. And actually some scale actions, in this case on the storage in the public cloud, in order to save money and save capacity that's not needed potentially, which would, again, kind of fall back into this cost and ultimately carbon footprint of a particular environment. To get onto a specific CO2 related action, if I go into the entire set of actions here, you'll see there's a whole raft of them, including deleting wasted storage, which you'll see in our customer example was pretty key for a particular client. But here we've got a suspend action for a host. Now, the reason that we're coming up with this action is actually because we've set a desired state of utilization. We've told the system in this data center, in this cluster, wherever we've configured it, we want the environment to run at 80% utilization, plus or minus 5%. And we've actually figured out with the Turbonomic actions by organizing the environment in a better way, by scaling down unnecessary excess capacity, we can actually get rid of a host and still meet that utilization goal. And so we're telling you, hey, you can turn this host off. Now, what we're able to do in Turbonomic now is actually through our reports backend, you can configure as a customer your PUE in that data center, the emissions factor, and any renewable energy percentage, and we'll actually express that suspend action in terms of the power saving annualized, and also in terms of acres of forest, number of trees, CO2 emissions, and whatnot. So kind of bringing home really what those actions and the impact of them would be, as well as tracking the VM to host density. Now, just to kind of jump back for a second to the collateral for the presentation, what we can actually start to look at on those dashboards, as I've mentioned, is around what's happening with the sustainability overall within Turbonomic. We've also got some really cool capability to export that now to Envisi. I don't have time to show Envisi today, but Envisi obviously allows you to report on your ESG posture. And in the future, we're actually working on a dashboard to itemize that per application, which is very cool. Now, a customer case study I promised you. Here's a very large US bank. Over the years that we've been working with them, we estimate that there's around 30,000 metric tons of CO2, which is pretty impressive. You can see how they've achieved that at each of the stages by kind of decommissioning and repurposing storage, density gains on the planning side, capacity gains, cost avoidance as well along the way. And 30,000 tons of CO2 is equivalent to about 6,000 homes electricity use for a year. So nothing to be sniffed at in that case. Now, coming up next, we've got Fred Klein talking about Watson AIOps. Now, the way that Watson AIOps kind of plays, if you like, with Turbonomic is that can take a much broader view across a lot longer time horizon and with more data sources. And one of the sources that it can work with is trouble ticketing. So we can send Turbonomic and Installer data directly to Watson AIOps, or another route, if you like, for that integration point to work on is for any of the actions within Turbonomic, we're actually able to specify, instead of raising them or automating them within Turbonomic, you might want to actually pass them out to an external orchestrator, an ITSM system. So maybe I want to cloud scale actions. I want to pass out, instead of generating the actions, I want to pass them to an orchestrator, either pass them and forget about them and the orchestrator, the ITSM system, will take care of them, or maybe I want to get approval back from the orchestrator for this action before Turbonomic goes off and executes it. And because we've got a ServiceNow integration out of the box, we can actually get an approval of that action. These workflows are imported from ServiceNow. We can map directly into them from within the Turbo UI. So pretty cool capability, and it also enables some of the actions to be understood by Watson AIOps through their integration with ServiceNow as well. So having said that, I'll pass you over to Fred and we'll hear all about Watson AIOps.
Thank you, Alec. And with that, let's dive into AIOps. Why do we have the Cloud Pak for Watson AIOps? Why do we need it? And why is it a good idea to combine it with observability via Installer, as well as Application Resource Management, as we've seen it from Alec in the ARM tool from Turbonomic? Well, the Cloud Pak for Watson AIOps is application-centric. And because we do have with Installer and Turbonomic already insights about how these things are connected, about performance metrics, maybe some log entries, all that is available. And we add with the Cloud Pak for Watson AIOps additional insights. So we learn from the behavior of the applications, what is normal, and then we can deduct what is abnormal behavior. So we can learn from operations how incidents and problems are managed and what kind of problems they did resolve. That can be learned, and that can be learned via using the Cloud Pak for Watson AIOps engine, and the engine is inherited from Watson Analytics. What it provides is natural language processing capability. So we really understand written and spoken text. We do not care about tone analysis. That is how far the Watson engine is capable of analyzing the data. On the left side, we do get via so-called connectors data, structured data and unstructured data into the system. Time series data, which we call here metrics, or problems that occur in your environment. Something has gone wrong, something has been broken, something is no longer reachable. And we do get information about that via events and alerts. And we do also learn what observability and application resource management has connected to each other. That's what we call topology data. Also from network environments, from discovery engines, from CMDBs, from log information. All these kind of things do provide bits and pieces to the full story, and the Cloud Pak for Watson AIOps is capable of piecing all that together around an application, and not just one, multiple applications. And as we learn what's normal and abnormal and how operations is dealing with the issues in there, then we can also combine these kind of insights with current problems. So we learn from the history how things are dealt with, and we can suggest exactly problem solutions to similar incidents. And that's what we do. We apply the AI capabilities to visualize things that we haven't known before, as well as we get additional insights in here, and we provide trustworthy actions and try to automate as much as possible. Just think of the 10% or less of the few people who know everything about your environment. They know how to resolve things. They know exactly how things are connected. And these people can provide really good insights into how do we need to address specific problems. They can write it down. This is something we have typically collected in a knowledge article or a database or wikis, and all these kind of things can be learned and connected. And that's adding context to the various pieces and really piece them together, make them as easy to use as possible. So a runbook, that's how we call these kind of procedures, may be attached via a context to an application, to a specific problem, and suggest how to resolve that kind of thing. As well as we may add value here by suggesting something that has been resolved in the past and may provide insights into a current problem, which is not exactly the same error message, but maybe similar. And this similarity is deducted using the IOPS engine, because we're not just using a simple distance function, something like a Levenstein function, where we just twist a few digits and then we have more or less the same error code. No, we really understand the content of the problem, how it's structured, what kind of things to have led to this kind of issue. In this specific use case, I want to demonstrate what the change risk analytics is doing. This is showcasing exactly the whole principle of the Cloud Pak, because we have to learn data firsthand, then we will see the quality of the data that we have learned. And once we have learned the data, then we turn it into a model that gets deployed. And then we switch the learning mode into continuous mode. So once we have an initial model, then we can continuously continue to learn. And then we can use that kind of model data to exploit it. Do we have something like an additional insight in here? In the change risk, of course, this is analyzing planned changes. We go into a trouble ticket system. In this case, we are going to look into ServiceNow, and we're analyzing planned changes. And as soon as they are confirmed in there as a planned change, then the engine analyzes the data and adds a risk status in here. So we come out with a confidence level as well as a risk estimate, for example, low, high, or medium risk change. And we also provide data. Why do we have this kind of risk estimation done in here? Now let's get into the demo. So here is the Cloud Pak for Watson AIOps login screen. Let's have a look into the connections and how data is going to flow into the system. So this is the connection screen where I can define all connections. So out of a library of existing templates, I can create new connections or modify ones. And I want to connect to a ServiceNow instance, and I want to create a new connection. So for that, I need to provide a number of configuration details. Well, of course, give it a name, the URL, credentials, and where is it residing. Let's test the connection, if it's available or not. Yeah, it's done. And for the moment, we do not want to collect topology data, but we want to collect ticket data, because that's where the changes are in. And as you can see in here, there are multiple modes available. I can do an initial loading, that's from the historical data. And I can switch to continuous learning as well. And if I go into the history, I need to provide a time frame. So let's go back a few years and learn the data that is available in that environment. So ticket types, that's the changes and incidents that we want to see and analyze. Now we have configured the connection, and here it is. As you can see from the categories, we can collect in here ticket data as well as topology data from that data source. Now, as an output channel, we want to connect ChatOps connectivity. We select Slack, and let's provide a few extra things in here, how to provide this kind of Slack channel. Now we've configured the two data channels we're looking to. And let's go into learning data. So this is in the AI model management section. This is where I can administer change risk model. Let's give it a name, and this will be our schedule. So we want to have it first in initial training, and later on we want to switch it to continuous learning. Now we have an initial job configured. Now, as you can see, version 0 is here. That means we do not have an initial model deployed, so therefore we need to learn for the first time to create a model. And you can see here, not started and run manually, so we need to kick it off manually. So this is quite a nice screen because it provides you with a lot of insights. So first of all, the status of the training, as well as it gives you an insight into what kind of data is available. So by hitting the start button here on the upper right, we kicked off the learning mode. So now the data collector is fetching the data from ServiceNow. And as the data is pouring into the system, it gets analyzed. And we will have visual feedback about what kind of data we have, the data quality that is coming back into here. And that gives us an indication how usable the data is. So data quality can be an issue if it's too low. So let's see what kind of training data we get back. So now we have feedback in here. We're in stage 2 of 3. The data quality is good. Now the training is finished, and we actually can deploy the model. So by hitting the deploy button, we can undeploy that model we've just deployed. So as you can see here, overview details, version 1.1 is deployed. Now we have a first model in place. So now we need to go into our trouble ticket system and create a new change request that we're going to have evaluated by the engine in the backend system. Of course, we need to provide a number of details in here. Let's just fast type it. So we're going to upgrade an SQL database from a version to another version. So this is the implementation plan. We think it has a small risk. The backup plan priority is moderate, and we need to assign it. Okay, now we have created a change. Here it is. And as we can see, the system has already evaluated our change request. And it turned out that it is a high risk. And we have a confidence score of 97%. And the reason why the risk assessment has come back to high risk is given with these change requests that have created previously a few problems. So you can click on each of those changes that have been done, and that is evidence why the system came back with the evaluation into high risk. If you want to know more details, just click on the links, and then you will see what has gone wrong, and that is very valuable insight, because with that kind of insight you can now alert your administrators that this planned change is a high risk one, and they need to be very on alert to, just in case something really bad happens to your application and you need to back out. So this is it, what I wanted to show you for change risk. As you can see, we have feedback in our Slack channel. In here, there's feedback about the evaluation of the change risk. Here's the link into ServiceNow ticket. We have the results in here. So everything is represented in the Slack channel and can be seen in here as well via Alps. So with this, I want to conclude my demonstration. I hope it gave you a brief insight into the way how the Cloud Pak for Watson Alps works, what to expect from it, and with that, I hand back to Thomas and John. Thank you very much.